Welcome to agarose gel electrophoresis for the separation of DNA and RNA. To prepare a 1% agarose gel, begin by weighing out 1 gram of electrophoresis-grade agarose into an Erlenmeyer flask. Add 100 milliliters of 1X TAE buffer to the agarose. After loosely covering the flask, place it in the microwave for about 2 to 3 minutes to dissolve the agarose. When removed from the microwave, the agarose should be completely dissolved. Set the solution aside to cool. While the solution cools, assemble the gel casting tray. Place the sample comb into the tray. Place the tray in the gel casting apparatus and tighten the lever to form a tight seal. Before the solution solidifies, add 4 microliters of a 10 milligram per milliliter stock solution of ethidium bromide. Carefully pour the agarose solution into the tray and allow the agarose gel to solidify. While the gel solidifies, you may fill the buffer chamber with 1X TAE buffer. When the agarose has set, carefully remove the gel in its tray from the casting apparatus. Place the gel into the buffer chamber, aligned so that the sample comb is closest to the black lead. You may now remove the sample comb. Mix your samples with the green loading buffer and carefully load the sample wells. Using a white background may make visualizing the wells easier. After loading the wells, attach the lid to the chamber matching the black and red leads. Turn on the power supply at 120 volts. You should observe bubbles forming at the anode. After a few minutes, you should also observe the dyes in the loading buffer begin to separate. When the orange G dye reaches the bottom, turn off the power supply. The presence of ethidium bromide in the gel allows us to visualize the DNA bands without an additional staining step. Place the gel on a UV illuminator and turn on the UV bulbs. Ethidium bromide intercalated into DNA strands will result in bright pink bands. We hope you've enjoyed this Lutz Lab production. Join us again next week for SDS Page, The Saga Continues.